So the first question is question 7, which asks to show that the random telegraph signal is a strict sense-stational process. So we know that the random telegraph signal takes, it's a stochastic process that takes two possible values with a fixed probability in each time interval, and the process changes randomly between the two interval of the two time value, and the transition time following an exponential distribution, and we can call it A and B. And we know that the expected value of t equals to 1 times probability of xt equals to 1, and -1 times probability of xt equals to -1, because the value can only be 1 and -1. And here the probability p is the probability that the process take the value 1 or -1 and at a given time. So the mean of the RTS is constant, and we can calculate the autocovariance of this. So it's expected value of xt times xt minus k. So we can consider the variance at k if k equals to 0 and k greater than 0. So if k is equals to 0, then we have the autocovariance equals to expected value of xt squared. And if and we can express it like covariance of 0 equals to a squared p plus -1 square 1 minus p. And if k is greater than 0, then we can have expected value of xt times xt minus k, which is the covariance, and it is equals to expected value of at times at minus k minus expected value of at times bt minus k minus expected value of bt times at minus k plus expected value of bt times bt minus k, where the constant exponential distribution switches between A and B. And so we can see that the variance is expected value is xt, which equals to expected value of xt squared minus xt expected value of xt squared, which is equals to 1 squared times the probability of xt equals to 1 and plus -1 squared times probability of xt equals to -1 minus expected value of x squared. So the probability of xt being 1 or -1 depend on the history of the process up to time t, but it do not depend on t itself. So the variance of xt is a constant over time. And that's it. That's it for question 7.